Hi there, thanks for watching. This is the demo of the Anka MCP server. I'm going to explain just a little bit about what it is and then we'll jump right into showing you how it works. So, like any other MCP server, you're going to deploy it on a Linux machine and it is going to be the interface between what you want to happen and the agents. And we have spent a lot of time making sure that the Anka MCP server only does exactly what it needs to do and minimizes the risk to your cluster and setup, so that there's very little security risks here for agents. They can't just run havoc on your setup. So the MCP server supports um, two different use cases: the controller, which is the Anka Build Cloud Controller, and the local, just running directly on a Mac host and interfacing with the Anka CLI to spin up VMs. We are not going to do the local demo. We are going to stick to the Anka Build Cloud Controller. And let me actually load that up here. So let me show you. Oh, wrong button. So the controller is between your CI/CD and automation, and it basically just takes requests from an API. It has an API and it takes requests to then communicate with the hosts that then spin up VMs. So each host has Anka virtualization or the Anka CLI on it, and they're Mac hosts, and then you can run the controller in its registry, which stores those images, or we call them templates, on each host. And the hosts then pull down the templates from the registry and then clone from them and run the VMs for whatever's making that original request to the controller. So I'll close that here, and then setting up Anka MCP, I'm not really going to go over. It's just an npm package, so you're just going to install it like you do any other node package. And then it does have an ability to create client tokens per client. So it has an admin token, and then you generate client specific tokens which isolate anything that an agent requested from each other. So if team 1 has their own token and team 2 have their own token, they're not going to be able to influence each other's instances. They can't try to start or stop or terminate or do anything. They won't overlap at all. They'll be completely segregated. So the controller has 4 different tools here: list templates, request a VM, get the VM and its status and information, and then terminate the VM. So that's pretty much all I'm going to show you. Check out the README. It is a public repo as well. It is open source. We would love contributions, so feel free to contribute. But let's jump into the demo here. Here's my controller. So this is showing 9 active nodes, 18 more instances available. They are all completely empty, and they can run 2 VMs each. And I have one template, which is a 2632 Macintosh VM template. It has one tag, which is just vanilla Macintosh, and it's in a stop state. You can have multiple tags for like different Xcode versions, for example, and the agent will, depending on what you tell it or what's in the project, basically, if it has a requirement for a specific Xcode version, it will list the templates and tags and see that specific Xcode version and use that to spin up the instance. And I'll show you more about that later. Here's the instances page that's empty. I could manually create one if I wanted, but the agent won't have access to that. So we're not going to demo that. We're just going to show you how it works in Cursor here. So in Cursor, I've got the tools already set up. So you can see there's 4 different tools, as I said, and they have instructions available to the model or agent. I'm going to use Composer 2.5, and I basically said in the prompt, run some tests against the MCP tools for Anka, and then SSH and check the VM stuff too. So I'm intentionally being a little kind of like vague to see what it does, and then you can ignore all this stuff. All right, great. So I think we're ready to go. So let's do our first test here. Let's go ahead and hit start. So it's looking through the MCP stuff. It got it. It read all the stuff. Yep, cool. It ran the controller list. So it got the template that's available and its tag. That's perfect. So that's working. It created an SSH key on the local machine here. And then it sent that SSH key in with the template ID that it wanted. And it set the name of stuff. Here we go. Cool. And it actually started right away. So it didn't have to pull because the hosts were pre-cached with the template already. So it started, and then it got information on how to SSH in. So this is the host IP and the forwarded port. So you're not having to go into the host and then into the VM. You're going directly to the host on the forwarded port and getting right into that VM. Basically some instructions on wait and then try to SSH in, wait a little bit for the VM to start. So looks like yeah, there we go. Okay, using the correct key, I had to fix the key, and so it SSH'd into the host at that port, and here we go, 2632. The host name is Anka's virtual machine, and some details about the VM. So this is working. It's exactly what we want to see. It's doing some more SSH stuff here. And then it terminated. So terminated this instance ID and then true as the terminated, and then it cleaned up the SSH key from the host because it was temporary. Cool. So all of these passed. That's exactly what we wanted, and it's just describing the results that we got. So this is great. So this is working. But now what we want to do is we want to use subagents and pack the available 18 instances with 18 subagents, each having their own VM. So imagine you want to take like a huge mono repo that has a bunch of different tests and stuff. You want to split them. You want to have an agent control testing. Well, spinning up the agent and then running the test suite inside. So you don't want to have like very fixed automation for that. You're just going to use it, an agent to handle that, or a bunch of sub agents to split the tests across a bunch of different machines so that you can parallelize them and speed up your test suite. That is possible. And the great thing about the cluster here is we have a bunch of hosts available with a bunch of capacity. So what I'm going to do is come back here, and then I'm going to tell it to spin up a bunch of subagents. Okay, so here's the prompt. Okay, now spin up 18 subagents, each requesting their own VM, have them all SSH in and get the SWVers info. So let's go ahead and run this and see what happens. All right, starting up. We'll do agent 1 and see what it's doing. So yep, it's generating the key. And the main agent passed in a bunch of context, so it doesn't even have to like go through a bunch of thinking. Okay, so this one's requested and it's named parallel test 1. If I come here, I'm going to see that a bunch of them have started, some of them are scheduling. This is parallel test 5, and you can actually see the external ID set with as much context as possible. So we know it's Anka MCP that started it. We got like client, the IP, the session, the credential ID. So, and then the ref. This is the ref that like here, this external ID that's set. This is 1, but you know what I mean when I'm the 5 is just agent 5. So if we go back here and pull that up, we'd see. Yeah, right here. Anyway, so these are going to be spun up, and we can see that a ton of them are already started and ready to go. And let's go back to the aggregate listing here. So these are complete. These are looking great. You can see some of them are VM test passed successfully. Yep, and it cleaned up after itself. Ran SWVers. It got the version back. And yep, some of these are now being terminated, so that's good. Okay, some of these are still sleeping. Sleep 25, yeah, so it shouldn't take very long. Yep, terminating, okay, so almost done. Completed. It's really cool to be able to see them all work this way. Okay, I think the last one is just terminating right now. Yep, should change to terminated. There we go. Okay, so they all finished. They all passed. All first tries. There's no like delays. 9 agents hit this on the first SSH attempt, but they're supposed to wait. That makes sense because the VMs take time to start up. So SSH isn't available immediately, even if it gets an IP. It can take a little bit of time. So that is totally fine. It's doing what it should and retrying. Okay, cool. That's it. Yeah, so that's the that's generally the use case and demo for the Anka MCP. So you can also use the controller for normal CI/CD. So like Jenkins can interface with it to request VMs for jobs as normal, and now your developers can also with the MCP server use the VMs as well for local development. Yeah, so give it a shot, give it a try, contribute if you find some issues or some features that are missing. Otherwise, thanks for your time.